So in this section, you're going to watch me convert a Java application to Kotlin. And the application I'm going to convert is a text adventure game. Now, if you don't know what a text adventure game is, I think showing you will be easier than explaining it. I've opened the IntelliJ project that contains the text adventure game, and I'm going to go ahead and run the application. Okay, so this game doesn't have a graphical user interface. It's a text adventure game, and so it outputs everything to the console and it accepts input from the console. So when we run, we'll see a message that says, "You are at a complex junction. A low hands and knees passage from the north joins a higher crawl from the east to make a walking passage going west. There is also a large room above. The air is damp here." So essentially, you're getting a description of where you are. And then it says available exits are Q, which stands for quit in this game, U, which is up, E for east, N for north, and W for west. And essentially, the game is now waiting for you to tell it which direction you want to go in. So I'm going to go up. And now it says you are in a large room full of dusty rocks. There is a big hole in the floor. There are cracks everywhere and a passage leading east. And now we have a different set of exits. We can quit. We can always quit. Or we can go back down. Of course, since I went up, that will just take us back to where we were. Or we can go east. So let's go east. And it says you are in a dirty, broken passage. To the east is a crawl. I think that should be, I'm not sure why it just says crawl. Crawl space maybe. To the west is a large passage. Above you is a hole to another passage, and then we can choose where we want to go, but I'll quit at this point because I think you get the point. And it says you are sitting in front of a computer learning Java. Now it says you are sitting in front of a computer learning Java because Tim Bachalka uses this code in his Java masterclass. So if you've taken Tim's Java masterclass, you probably going to be familiar with the code, or at least you've seen it. And I am using the code with his permission, so no worries there. So essentially, this is a game that puts you into a location and it describes the location and then you tell it which directions to go. Now, if you're my age and you used to play adventure games, you'll know that they could do a lot more than that. In some locations, you could pick things up and you had an inventory. So there were some puzzles, etc. I think when I played them, there were two really popular ones. There were the Zork ones, and there was also one based on Hitchhiker's Guide to the Galaxy that everybody seemed to want to play. And, you know, if you're young and you're one of the gamers who's only ever played a game that has a graphical user interface, well, these are games that we in the previous generation used to play. And of course, you may be looking at this and thinking, how could that be fun? Well, they were a lot of fun because it was what we had. And of course, in 20 years, there'll be gamers looking back at the games that we play now and saying, you know, what terrible games. How could people play games that are so limited and have such a crappy interface? So it's just the way things go. Progress marches on. But this is a text adventure game. So now that you know what this game does, let's take a look at the Java code so that you can see how this game is coded, and also so that you can see the code that I'm going to convert to Kotlin. And I'm going to go through the code quickly because it is Java. So let me shut down the console. And the first thing I want to point out is that this game has two text files. There are 4 here, but it's actually only using the directions_big.txt and the locations_big.txt files. So let's take a look at locations_big.txt, and you'll see that this file contains the information for a location, except for the potential exits. So it contains the description of the location that we see in the console. You'll remember that when we quit, we saw you were sitting in front of a computer learning Java. Now I happen to know that this game always starts out at location 64, and we'll see that in a minute. So if we scroll down to location 64, we'll see you are at a complex junction, a low hands and knees passage, etc. And we saw that in the console when we first fired up the game. So 64 is the location ID. and every location has one. So the format of each line in the locations underscore big.txt file is you have a location ID, which is an int, followed by a comma, and then followed by the location description. So now let's take a look at the directions underscore big.txt file, and we'll see that this one is quite different. Each line in the file contains information for one direction. And the format is you have the location ID, and then you have the direction, and then you have the destination location ID. So the way to read this is if you're at location 1 and you go west, you will end up at location 2. If you're at location 1 and you go up, you will end up at location 2. If you're at location 1 and you go east, you will end up at location 3, and on and on. All right, so now that we know what the data looks like, let's take a look at the code. There are 3 classes in this application. It's a small application, but it does more than print Hello World. But don't worry, if you love Hello World, we are going to do that later on because it wouldn't be a programming course if we didn't have Hello World in it. So let's start with the location class. So this is location.java, and you'll see right up there com.timbachalka as the package. So this class stores the information for a location. So we have the location ID, which is an int. We have a description, which is a string. And then we have a map that contains the exits. It uses the letter for the location as the key. So you'll remember back in directions.txt, these are all the directions and they're represented by the letters. So the letter is actually the key, and then it will have the destination location ID as the value. Now you'll notice that in the constructor, we're adding Q to every location. So we're not cluttering up the directions underscore big.txt by having a Q direction rather for every single location, because that would just be wasteful. I mean, if you hit Q, it doesn't matter what location you're in, you're going to quit. So we just add that, and the location ID for the quit location is 0. And if we go back to our locations big.txt and scroll to the top, we'll see that location ID 0 is you are sitting in front of a computer learning Java. All right, so the location.java file stores the location, the information for a location, and other than that, it doesn't do anything special. You can add an exit, and we'll see that in a minute. All right, so now let's take a look at the locations class, location with an S. And this is the class that reads in the 2 data files. Now, I'm not going to bore you with the details. I'll just point out that we're using a scanner to parse each line in the file. First, we read the locations underscore big.txt file, and we create all the location instances. So right here, we're reading in the location ID, then we're reading in the description, and at that point, we're creating a location. And you'll notice that we're saying locations.put. Loc would be the location ID, and then there'll be the location instance. And locations, if we go to the top here, is a map of integer and location. Integer is the location ID, and then location would be the location instance. So after we've read all the locations and we've created a location instance for each one and put it into the locations map, we then read the exits. And we use the location.addExit method to add the destination location for each direction. And if we go back to location, add exit, you'll see that all we're doing is adding the exit to the exits map up here. Now, if we go back to locations, you'll notice that all of this reading takes place in a static initializer. So the files are read in the first time the application uses the locations class. Okay, so all that's left now is to take a look at the game logic, and that's in main.java. So right at the top of the file, we assign a static variable in the main class with the locations field. And we'll remember that that's the map, the static map up here. So this locations map contains a map of location IDs followed by location instances. And we're storing that into a locations field that's declared within the main class. And this is the point where the static initializer will be called. So essentially, as soon as an instance of main is being created, the locations static initializer will be run and the two data files are read in. And then at that point, of course, after that happens, the JVM is going to call the main method, which contains the game logic. So the first thing we do is create a scanner that's going to read user input from the console. And then we set the initial location to 64. Remember, I said that I happen to know that the game always starts at location 64, and this is why we could use a random number here, but we're just setting it to 64. There are some versions of this code that do use a random number. And then we have a deliberate infinite loop, and inside we read the description for the current location. So since location is set to 64, the first location we read is going to be 64, and we get that location's description and print it to the console. Now here we check for location ID 0 because that's quit, and if the user wants to quit, we break out of the loop. The first time through, of course, we know it's not going to be 0 because it's set to 64, and that's fine, so we just don't break out of the loop. But even if the location is 0, we still want to print the description because we still want the line "you are in front of a computer learning Java." We don't just want the game to quit without printing anything. All right, so if the location ID isn't 0, we get the location's exits and then we print them out. So here's the available exits are, and then we loop through the exits and we print them out. And then we wait here for the user to tell us which direction they want to go. When we have the user input, we check to see whether it's a valid direction. So if the available exits are Q, N, and W, and they type Z, then this check will fail and we'll print out "you cannot go in that direction," and we'll loop back up, print out the description of the current location again, and wait for them to give us another input. If the direction they give us is valid, then we go to the exits map and we get the destination location. So we got the exits here, that's set up here, and that is the current location's exits map. And so we check that map and we get the ID for the destination location. So loc will now contain the destination location. We loop back up and we print the description for the new location they're at and check for 0 again and rinse and repeat until we do get 0 because the user wants to quit. So that's it. Straightforward, but it's doing a little more than hello world. So in the next video, what I'm going to do is I'm going to convert this application from Java, which you've now seen, to Kotlin. So I'll see you in the next video.